Our next section is called Counting by Complement, and this section shows us how we can turn a problem that may be difficult to solve or difficult to answer into something pretty simple. And it uses this very simple rule that is pretty obvious when you really think about it. Here's the rule. The number of elements in a set that have a certain property can be found by taking the number of elements in that set and subtracting the number of elements that do not have the property. So let's say I have a bowl of M&Ms. Then I could say that the number of M&Ms in that bowl that are red would be equal to the total number of M&Ms minus the number of M&Ms that are not red. Now you might think that might be harder in the case of M&Ms, but you'll see that there's a lot of other situations where it's easier to solve the problem if we use this rule here. So here is the notation if we want to put it down in writing. Let's say that we're going to call P the set containing the elements of our original set that have a certain property. Then P with a line above it would be considered the complement of P, and that would represent the sets in that original set. I'm sorry, the elements in that original set that do not have that property. So capital P with lines on each side means the number of elements with that property in S is equal to, and then we have the number of elements in S, because we have S with those two lines, minus the number of elements in S that do not have the property. Okay, so sometimes this really helps us to turn something into a pretty easy problem, and we'll see some examples here. So let's say that we're trying to answer this question. How many 4-bit strings have at least one 1? Now remember, the 4-bit strings we would be talking about would be strings of zeros and ones, and then there would only be 4 digits because it's a 4-bit string. So we'd have 4 digits all consisting of either zeros or ones. So we can use what we just learned, this complement property, and say the number of 4-bit strings that have at least one 1 would equal the number of 4-bit strings in general minus the number of 4-bit strings with no ones. And we'll see that that ends up being pretty easy. So first of all, the first part, the number of 4-bit strings. Well, there would be 4 slots. And if we're just talking about 4-bit strings in general, we don't have any restrictions. We'd say, well, there's 2 possibilities for the first slot, a 0 or a 1. Same thing for the second slot, and so on. So we'd have 2 times 2 times 2 times 2, and that would equal 16. So that's the first part of this. It's the number of 4-bit strings in general. But now we would want to subtract the number of 4-bit strings with no ones. Let's see if we can figure that out. The number of 4-bit strings with no ones. Well, if there are no ones in there, then let's think about how many options there are for each slot. We'd have to have 0, 0, 0, 0 as the only 4-bit string with no ones, right? So how many options are there? Only one option for the first slot, one for the second, one for the third, one for the fourth. Okay, so again, that top line, that line of zeros is just saying this is the only 4-bit string that would satisfy that. It's just the 4-bit string with just zeros in there. And then below, this is how many ways can we fill each slot using these, staying with these requirements. So it would be 1 times 1 times 1 times 1, which is equal to 1. So the number of 4-bit strings that have at least one 1 would equal 16, which is the number of 4-bit strings in general, minus 1, which is the number of the complement of what we were looking for. So it would be 16 minus 1, and we end up with 15. So 15 would be the answer to that question. Okay, here's another problem. Let's say that a classroom has 7 girls and 9 boys. First of all, the first question is, how many ways are there to select 3 students? So let's say we're picking a committee out of that classroom of 3 students. Well, how would we do that? Well, remember that would be just the number of students possible, and we choose 3 at a time, right? So it would be 16 choose 3. Or we could write that as the capital C with 16 first, then comma 3, right? That would be the combination of 16 things taken 3 at a time. Okay, well, what is the formula for that? We know that the formula would be the 16 factorial over that 3 factorial times, and then what's 16 minus 3? That's 13. So it would be 3 factorial times 13 factorial on the bottom. Now, we might say, well, should we go on and find that number? And we could, and it wouldn't be that hard. But I think I've said before that usually zyBooks is wanting you to just answer in the terms of either a 16 choose 3 or this combination with a 16 comma 3. So you would probably not even then have to turn that into and use the formula. You'd probably just answer it either with a 16 and 3 in the big parentheses, or just actually type out the words 16 choose 3, or put it with a capital C and then the 16 comma 3. Okay, that's just how many ways to select 3 students in general. So we haven't used our new rule yet. But let's say that we're asked now, how many ways are there to select 3 students so that at least one girl is chosen? Well, we could, the trouble is there's lots of different ways. We could have 3 girls or 2 girls or just 1 girl, right? So to simplify it, we'll use this complement rule. The number of ways to select 3 students so that at least 1 girl is chosen would equal the number of ways to select 3 students, which we just found, minus the number of ways to select 3 students with no girls chosen. And that's going to be even a little easier. So first of all, that first one we've just found was 16 choose 3. And then we would subtract, and let's figure out what that would be here. We would have the number of ways to select 3 students with no girls means that we've got just the boys to choose from, right? We're going to ignore the girls for now and just choose 3 of the boys. So that would be 9 choose 3. Hopefully that makes sense, because we're just taking 3 out of the boys. So that's 9 choose 3. So we could get the answer by taking 16 choose 3 minus 9 choose 3. And again, we could go and use the formula, but we won't. And with zyBooks and also with the problems that I ask, even on the test, I would have you answer in these terms, like just type in 16 choose 3 minus 9 choose 3, or this with the combination. So capital C 16 comma 3 minus capital C 9 comma 3. Okay? And again, as I've just said, you can leave your answers in that form. Okay, how many 8-bit strings do not begin with 0, 0, 0? Okay, well, we could look at it as, let's find the number of 8-bit strings in general and subtract the number of 8-bit strings that do start with 0, 0, 0. We could find that, okay? So, first of all, number of 8-bit strings, there would be 8 slots. How many choices for each slot? 2 for each slot, so we would have 2 to the 8th. So that's how many 8-bit strings we have that are a possibility. But then let's find the number of 8-bit strings that start with 0, 0, 0. Well, we'll have 8 slots, but we'll start out with the first 3 digits as 0. So we don't have any choices for those first 3. But now, how many choices do we have for the remaining slots? Well, we'd have 2 choices for each of those remaining slots. So it would be 2 times 2 times 2 times 2 times 2. That would be 2 to the 5th. So our answer would be 2 to the 8th minus 2 to the 5th. And again, we could find the answer, but we'll just be leaving our answers like this. Now, for Zybooks, what they'll want you to do if you have something like this with an exponent is they'll want you to use that caret symbol like this. 2 caret 8 means 2 to the 8th. So you'd have 2 caret 8 minus 2 caret 5, and that would be giving the correct answer in Zybooks. Okay, let's do another one. How many serial numbers of length 12 are possible if digits 0 through 9 are used? Well, that would just be, there's 12 slots, and there's 0 through 9 would be 10 different possibilities. So we have 10 times 10 all the way 12 times, and so that would be 10 to the 12th power. How many serial numbers of length 12 are possible using digits 0 through 9 with at least one 5? Well, we could find this, the total number of serial numbers minus the number of serial numbers without a 5. Okay, so a total number of serial numbers in general would be 10 to the 12th. Now, number of serial numbers without a 5, well, we would just think about it this way, that we still have 12 slots, but now for each slot, we only have 9 choices, because we could use 0 up through 4 and then 6 up through 9, but the 5 is not possible anymore, so we would be down one choice. So it would be 9 times 9 over and over to end up with 9 to the 12th. So our answer would be 10 to the 12th minus 9 to the 12th, or in Zybooks you would type it in as 10 caret 12 minus 9 caret 12. Now the caret symbol is on your keyboard, but you might not be familiar with where it is, but I think it's on my keyboard it's the capital 6, and I think that's probably what you would find in any keyboard. So look for that as the uppercase option for the 6, and you should find the caret. Well, that was a pretty quick section, and that's really all we need to cover for that. There are some exercises for you to complete in that section, so I definitely will want you to do those. But there's also an additional exercise that you might want to look at just to give you some extra practice. So that first additional exercise called counting passwords, that would be something that you might want to do, that you probably do want to do to get some extra practice. And I do have the solution open for that. So you can try to do the answer, try to get the answer yourself, and then check the answer by opening up that solution.